Part 21, let's go! So yeah, last time was the fifth quiz, and now inequalities, greater than and less than basics. Okay, so this one's already finished. So I'm pretty sure this is the same video from our previous sections. It's just
earliest
in here.
days of
So I guess I
arithmetic,
don't
you
need to
might
read
see something like
whatever, let's just rewatch it again.
Most of us are familiar with the equal sign.
I'm recording. That's correct. That's
From our earliest days of arithmetic, you might see something like 1 plus 1 is equal to 2. Now, a lot of people might think when they see something like this that somehow equal means give me the answer. 1 plus 1 is a problem. Equal means give me the answer, and 1 plus 1 is 2. That's not what equal actually means. Equal is actually just trying to compare two quantities. When I write 1 plus 1 equals 2, that literally means that what I have on the left-hand side of the equal sign is the exact same quantity as what I have on the right-hand side of the equal sign. I could have just as easily have written 2 is equal to 1 plus 1. These two things are equal. I could have written 2 is equal to 2. This is a completely true statement. These two things are equal. I could have written 1 plus 1 is equal to 1 plus 1. I could have written 1 plus 1 minus 1 is equal to 3 minus 2. These are both equal quantities. What I have here on the left-hand side this is 1. 1 plus 1 minus 1 is 1. And this right over here is 1. These are both equal quantities. Now, I will introduce you to other ways of comparing numbers. These are the equal sign is when I have the exact same quantity on both sides. Now we'll think about what we can do when we have different quantities on both sides. So let's say I have the number 3 and I have the number 1, and I want to compare them. So clearly, 3 and 1 are not equal. In fact, I can make that statement with a not equal sign. So I could say 3 does not equal 1. But let's say I want to figure out which one is larger and which one is smaller. So if I want to have some symbol where I can compare them, where I can tell, where I can state which of these is larger. And the symbol for doing that is the greater than symbol. The greater than symbol. This literally would be read as 3 is greater than 1. 3 is a larger quantity. And if you have trouble remembering what this means greater than, the larger quantity is on the opening. The larger on the larger, I guess if you could view this as some type of an arrow or I guess some type of symbol, that this is the bigger side. Here you have this little teeny tiny point, and here you have the big side, so the larger quantity is on the big side. This would literally be read as 3 is greater than, so let me write that down, greater than, 3 is greater than 1. And once again, it just doesn't have to be numbers like this. I could write an expression. I could write 1 plus 1 plus 1 is greater than, let's say, well, just 1 right over there. This is making a comparison. But what if we had things the other way around? What if I wanted to make a comparison between 5 and, let's say, 19? So now the greater than symbol wouldn't apply. It's not true that 5 is greater than 19. I could say that 5 is not equal to 19, so I could still make this statement. But what if I wanted to make a statement about which one is larger and which one is smaller? Well, if in plain English I would want to say 5 is less than 19. So I would want to say, let me write that down. I want to write 5 is less than, 5 is less than 19. That's what I want to say. And so we just have to think of a mathematical notation for writing is less than. Well, if this is greater than, it makes complete sense that let's just swap it around. Let's make, once again, the point towards the smaller quantity, and the big side of the symbol point to the larger quantity. So here 5 is a smaller quantity, so I'll make the point there, and 19 is a larger quantity, so I'll make it open like this. And so this would be read as 5 is less than 19. 5 is a smaller quantity than 19. I could also write this as, I could write 1 plus 1 is less than 1 plus 1 plus 1. It's just saying that this statement, this quantity, 1 plus 1, is less than 1 plus 1 plus 1. Less than.
Okay. I'll be back. I'm just gonna clean this. Okay, so I messed up. Today's May 14, yeah. And this is still a continuation of part 21, which was started on May 10. So yeah, I kind of messed up with that. Let's see. Supposedly I'm going to finish this section because I think there's only quiz 6 and 7 left, and then the master test. Yeah, quiz 5 take quiz again, so yeah, we're done. We're actually in quiz for this part. Yeah, let's do all of this today.
1 plus 1 plus
I really remember this video. Watch this. Okay, cool. Next, plotting inequalities.
I'm starting
Really recording though. Of course I am.
to take a little bit more care of my health, and I start counting my actual calories. And let's say C is equal to the number of calories I eat in a given day. Number of calories in a day. And I want to lose some weight, so in particular I want to eat less than 1,500 calories in a day. So how can I express that as an inequality? Well, I want the number of calories in a day. I want the number of calories in a day to be less than, and remember the less than symbol, I make the smaller thing on, I make it point to the smaller thing. So I want the calories to be less than 1,500. 1,500. So this is one way of expressing it. I say, look, the number of calories that I consume in a day need to be less than 1,500. Now, one thing to keep in mind when I write that is obviously if I eat no calories in a day, or if I eat 100 calories, or if I eat 1,400 calories, or if I eat 1,499 calories for C, those are all legitimate. Those are all less than 1,500. But what about 1,500 calories? Is it true that 1,500 is less than 1,500? No, 1,500 is equal to 1,500. So this is not a true statement. But what if I want to eat up to and including 1,500 calories? I want to make sure that I get every calorie in there. How can I express that? How can I express that I can eat less than or equal?
Okay, I'm back recording. Yeah.
That I can eat less than or equal to 1,500 calories. So I can eat up to and including 1,500 calories. Right now, this is only up to but not including 1,500. How could I express that? Well, the way I would do that is to throw this little line under the less than sign.
Less than or
now, this is not just less than. This is less than or equal to. So this symbol right over here, this is saying that C is less than or equal to 1,500 calories. So now 1,500 would be a completely legitimate C, a completely legitimate number of calories to have in a day. And if we wanted to visualize this on a number line, the way we would think about it, let's say that this right over here is our number line. I'm not going to count all the way from 0 to 1,500, but let's imagine that this right over here is 0. Let's say this over here is 1,500. How would we display less than or equal to 1,500 on a number line? Well, we would say, look, we could be 1500, so we'll put a little solid circle right over there, and then we can be less than it. So then we would color in everything less than 1500, and say, look, anything less than or equal to 1500 is legitimate. Now you might say, hey, but what about the situation where it wasn't less than or equal? What about the situation if it was just less than? So let me draw that too. So going back to where we started, if I were to just say C is less than 1500, the way we would depict that on a number line is, so let's say this is 0, this is 1500. We want to make it very clear that we're not including the value 1500. So we would put an open circle around it. Notice, if we're including 1500, we fill in the circle. If we're not including 1500, so we're only less than, we were very explicit that we don't color in the circle, but then we show that, look, we can do everything below that. Now, you're probably saying, okay, Sal, you did less than or equal. What if you wanted to do the other way around? What if you wanted to do greater than and greater than or equal? Well, let's think about that for a second. Let's say that I'm also trying to increase the amount of water I intake. What if you wanted to do greater than and greater than or equal? Circle 100, so we're only less than. We were very explicit that we don't color in the circle, but then we show that, look, we can do everything below that. Now, you're probably saying, okay, Sal, we want to make it very clear that we're not including the value 1500. So we would put an open circle around it. Notice, if we're including 1500, we fill in the circle. If we're not including 1500, so we're only less than, we were very explicit that we don't color in the space. Then or equal. Well, let's see the amount of water about that for a second. Let's say that I'm also trying to increase the amount of water I intake. And so let's define some variable. Let's say W is equal to the number of ounces of water I consume per day. Consume per day. And I've read that I should have at least, let me throw out a number, 64 ounces of water per day. So there's one way I can think about where I always want to drink more than 64 ounces. So that would be W is greater than 64. So I always want W here is the thing that I want to be bigger. So the opening is to the W. W is greater than 64 ounces. So how would I depict that? Well, let me do my number line right over here. Let's say that this is 0, this is 64. If I wanted to make it strictly greater than, so in this situation, it's not cool if I just drink exactly 64. That 64 is not greater than 64. I have to drink 64.01 ounces or 0.0001 ounces. It has to be something that is greater than 64. So I'm not going to include 64, but anything greater than that is completely cool. Now, what if I want to loosen things a little bit? I was like, okay, it's okay if I drink exactly 64 ounces or more. Well, then I could write W is greater than or equal to 64. And the way that I would depict that on the number line, and obviously I'm not showing all the numbers in between, but let's say this is 0, and then we go all the way up to 64. Well, now it's okay if I drink exactly 64 ounces, so I'm going to fill in the circle now. Here I opened it because 64 was not a cool number. Now 64 is completely okay. I can drink exactly 64 ounces of water in the day or more. And then I just go up the number line just like that. John is making pasta dough. To make the dough, he mixed 3/2 cups wheat flour with 3/4 cups regular flour and some water. Write an inequality to express the relationship between the wheat flour and the regular flour. So he mixed 3/2 cups of wheat flour. 3/2 is the exact same thing as 1 1/2 if we were to write it as a mixed number. So it's more than 1 cup of wheat flour. And he mixes that with 3/4 cups of regular flour. Well, 3/4 is less than 1. So 3/2 is definitely greater than 3/4. And we can write that, we can just pick greater than right over there. 3/2 is greater than 3/4. Let's do a couple more of these. One of the deepest points in the Indian Ocean, the Diamantina Trench, is at -8 kilometers. We say it is -8 kilometers because it is 8 kilometers below sea level. The deepest part of the Bering Strait is at -5 4/9 kilometers. Write an inequality to show the relationship between these 2 points and determine which point is deeper. So let's say we have a greater than sign here. So we want to write whichever quantity is greater on the left-hand side. So we look right over here. This number, -5 4/9, it is less negative. So it's actually going to be a greater value. It's not as deep. So we can write -5 4/9 is greater than -8, or -5 4/9 kilometers is greater than -8 kilometers. And so if we're thinking about which point is deeper, it's going to be the one that's more negative, because that tells us how far below sea level we are. So the -8 kilometer point is further below sea level, and that is, so let's see, -8 kilometers, the Diamantina Trench. Diamantina Trench at -8 kilometers is the deeper point. And this is fun, because in some of these questions you actually learn things. I always thought that the deepest part of the Bering Sea. Well, anyway, we can talk about that another time. So -8 kilometers. So Diamantina Trench. Diamantina Trench is deeper. Let's do one more.
Man, I want to see
John is
Mariana's Trench. Holy shit, of course.
John is making noodles. To make the batter, he mixes 11/16 cups tapioca flour with 3/8 cups rice flour and some water. Write an inequality to express the relationship between the tapioca flour and rice flour. So we're really comparing 11/16 cups of tapioca to 3/8 cups rice flour. So we're really comparing these two fractions. And at first it might seem hard to compare, you have different denominators, but 3/8 could easily be converted to a fraction with 16 as a denominator. What would you do? Well, if you doubled both the 3 and the 8, you have to do the same thing to the numerator and the denominator. This fraction, 3/8, is equivalent to 6/16. And then you would have the same denominator. You could compare 11/16 to 6/16. Well, if you have the same denominator and this numerator is greater, 11 is greater than 6, 11/16 is going to be greater than 6/16, which is the same thing as 3/8. And we got it right.
Just a sec. Okay, I'm back. Let's go. Inequality with one variable.
The Kármán line is the point at which the Earth's atmosphere ends and outer space begins. The Kármán line is at 62 miles above sea level, and any distance from sea level at the Kármán line or above is considered outer space. Set c equals 62 and use x to represent distance from sea level. Write an inequality in terms of x and c that represents the distances from sea level that are inside Earth's atmosphere. So we want to write an inequality in terms of x and c, and x is the distance above sea level, and c is the Kármán line, and we want to think about distances that are inside Earth's atmosphere. So that's going to be anything that's below the Kármán line. And so, let's see, I would write x is less than c, because they're telling us c is 62. Now I want to make sure, so they say the Kármán line is the point at which the Earth's atmosphere ends and outer space begins. So what if we're right at 62 miles? The Kármán line is 62 miles above sea level, and any distance from sea level at the Kármán line or above is considered outer space. Okay, so if I'm at sea or above, I'm in outer space. So only the things that are in atmosphere that are strictly below sea. So I'm going to do a less than, not a less than or equal sign right over here. All right, got it right. Let's do another one. A black hole is a region of space where the... All right. Got it right. Let's do another one. A black hole is a region of space where the pull of gravity is so strong that nothing can get back out once it has fallen inside. Let's use E to represent the largest distance from the center of the black hole that pulls objects inside. If x represents the distance of an object from the center of the black hole, write an inequality for safe distances from the center of the black hole in terms of x and E. So x is the distance from the center. E represents the largest distance from the center of the black hole that pulls objects inside. So if you're at E away or close, you're going to be pulled inside. But we want to think about safe distances. So if you're further away than E, you should be cool, and it's strictly greater than, because if you're at E, that's the largest distance that you would still be pulled inside. Very good.
Graph x is less than 4. So let's draw ourselves a number line over here. So let me draw a number line. Let me put, I'll start here at 0. So 0, 1, 2, 3, 4, 5. And we could go below 0. We'd have negative 1, negative 2, negative 3, negative 4. I could keep going. Now we want to graph all of the x's that are less than 4. But we're not including 4. It's not less than or equal to 4. It's just less than 4. And to show that we're not going to include 4, what we're going to do is we're going to draw a circle around 4. So this shows us that we're not including 4. If we were including 4, I would make that a solid dot. And to show that we're going to do all of the values less than 4, we want to shade in the number line below 4, going down from 4, just like that, just like that. And then we can just shade in the arrow just like that. So this right here is all of the values less than 4. And you can test it out. Take any value where there's blue. So there's blue over here, negative 2. Negative 2 is definitely less than 4. If you take this value right here, this 2, it's definitely less than 4. 4 is not included because 4 is not less than 4. It's equal to 4. 5 is not included because 5 is not less than 4.
We could use a number and to show the possible solutions to an inequality. Is greater. Wait, what? Greater than or equal to 2. Okay. Oh, I'm supposed to do this? Oh wow, cool. Okay. So x is greater than. So let's just put it. Okay, check. Oh, I'm supposed to. Okay, I made a mistake. I thought I was going to like select a number which can satisfy this equation to make it true. Okay. Less than 4. Less than 4. Do that. Okay. I'm not gonna do the quiz first. Let's do the exercises. Graph x is greater than or equal to negative 5. Alright, it's actually really correct. Wow. Okay. 1. Less than 1. No way, I made a mistake. Oh shit, this is negative 1. Oh god, my eye. Put it to 3, and then it should be like greater than 3 or equal. Okay, that's what that makes sense. These are the numbers less than 5. 5. Switch direction, not including 5. Okay, graph x negative 1 is greater than or equal to negative 1. Okay, cool, that makes sense. Less than 4, negative 4. Switch direction. Less than or equal to 0. Okay, cool. 2 greater than 2, it's an open circle. Okay, cool, makes sense. Inequality from graph. Showing the groups as the following graph. Oh, well, okay. So this is x is greater than or equal to 3. Now this x is less than or negative 2. Greater than or equal to 1. We have greater than 2. Okay. Cool. Writing numerical inequalities. Or dear. Haley's 117.39 her savings account. She has negative in her checking account. Oh, okay. Oh shit, okay. Why do word problems have 7 questions? I hate it. Nom 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 nom. His brother in year... What? Oh, okay. I guess it's LeBron. This is so strangely confusing. Okay. Wang Shuying as an Wait, what? Write an inequality that is true only for temperatures that are higher than the boiling point of water. The Mali Empire of West Africa was known far and wide for the great wealth of its rulers. The empire fell in the year 1610. Let the x represent any year. Write an inequality in terms of x and 1610 that is true only for values of x that represents year after. Okay. To cook a steak to medium rare, it needs to have internal temperature of 100 Fahrenheit. A lower internal temperature will undercook the steak. T is less than 135, I guess. Pink's Ice Cream Palace offers a special sundae that contains 2 kilograms of. Pink's Ice Cream Palace offers a special sundae that contains over 2 kilograms of ice cream plus any number of toppings. As the way of Wait, what? Pink's Ice Cream Palace offers a special sundae that contains over 2 kilograms of ice cream. Okay. Let's do the quiz. Red bird is flying at an elevation of 17.1/9 meters. Bluebird is flying at an elevation 10/35 meters. Which of the following inequality correctly compares the elevations? Kwame must earn more than 16 gold pieces per day to afford living in the city of gold. This is less than or equal to 1. Okay. Graph 5. Okay, let's go. Less than or equal to 5. Cool. Okay, cool. Got that. Now let's do two-step equations intro. Wow, okay. A bit lagging.
We are told that a race car driver has 28 cars. Each car has 4 tires. He has to replace all the tires on the cars. He has 22 tires right now. Estimate the total number of tires he needs to buy. So pause this video and see if you can do that. And the key word here is estimate. You don't have to figure out exactly. You just need to figure it out roughly, the total number of tires he needs to buy. All right, now let's work through this together. And as I mentioned, the key word here is estimate. And estimating is something we'll do throughout our life.
28 times 4, right?
Because I probably do it once a day at least. And when you're estimating, you want to make all the numbers roughly right, but also think about, hey, how do I need to think about them in order to make the computation a little bit easier or a little bit friendlier? So if I wanted to figure out exactly how many tires he needed to buy, I would say, hey, he has 28 cars. He has 28
Each
cars.
car has 4
Each
tires.
car has 4 tires. So each car has 4 tires. So if you wanted to know the total number of tires, you would multiply 28 times 4. And then it says he has to replace all the tires on the car. And if he didn't have any, this is the number that he would have to replace. But it says he has 22 tires right now. So if we were trying to figure out exactly, we would say 28 times 4. That's how many he needs to replace. But he already has 22, so you subtract that out. And then this whole number would be the number he needs to buy. Now, this calculation isn't so easy to do, especially if you're doing it on a napkin or in your head. But that's why we're going to estimate. So if we're estimating, we say, hey, what's a friendlier number than 28? Well, 28 is pretty close to 30. So I could say, so if I say, hey, 28 is pretty close to 30. So that's our way of making the 28 a little bit friendlier. 4 is already pretty easy to deal with. And then the 22, well, that could be a lot easier to deal with if instead of it being a 22, if that were, let's say, that's approximately equal to 20. So 22 is approximately, roughly equal, that's what these squiggly equal signs mean, to 20. And so that simplifies the calculation a lot. We could say that this thing up here is roughly equal to, he roughly has 30 cars, and each of those cars need 4 tires. And then he's going to figure out the total number of tires he needs to replace, but then he subtracts out the number that he already has. So instead of subtracting out 22, we're going to subtract out roughly how many he already has, roughly 20. And this computation right here is a lot easier to do in our head. 3 times 4 is 12, so 30 times 4 is 120. So this part right over here is 120. And then you subtract 20 from that. Well, 120 minus 20, well, that is going to be 100. So he roughly needs, if I were to estimate the total number of tires he needs to buy, it would be about 100 tires. We are told.
What should the word be rebels?
My book. We are told
coronavirus. Me.
Is 58 pages. I have already read 13 pages. I plan to read 5 pages each day until I finish the book. Which equation could I use to find out how many days, D, it will take to finish reading the book? So pause this video and see if you can figure that out.
Okay, my book's written. I have already read 13 pages. I plan to read 5 pages today to finish the book. Okay, let's say 58 minus 13 divided by 5, I guess.
Okay, so let's first think about the important information they're giving us. They're giving us the number of pages that are in the book. They're giving us how much we've already read. We've already read 13 pages. And they also tell us how much we plan to read. I plan to read 5 pages each day until the book is finished. And then we want an equation that it could use to find how many days, and D is how we're going to represent the number of days. Let me do it in the same color. It'll take to finish reading the book. All right, so if we knew how many pages we have to read, and we were divided by the fact that we're reading 5 pages per day, well, then that would give us the number of days. So how many pages do we have left to read in the book? Well, the book is 58 pages. We've already read 13, so we could subtract out 13 of those. So this expression right over here, this is how many pages we have left in the book. Let me write that down. How many pages left. And if we want to figure out how many days it's going to take to read these, we would divide this by how many pages we read each day. And we see that we read 5 pages each day. So if we divide this by 5, then this whole expression, let me do it in this color, this whole expression is going to tell us how many days left. How many days left. And so this is going to be equal to D, because D is the number of days left to finish reading the book. Now, if we look at these choices, that's exactly what we have right over here in choice C. We can make sure that these others don't make sense. 58 plus 13. No, that would be a situation where we're reading 13 pages more than the number of pages that are in the book. That doesn't make sense. And that's happening for both choice A and choice B. It would also not make sense to multiply by 5 because it's not going to take you 5 times more than the number of pages to read the book. You're going to divide by 5. You're reading 5 pages every day. And we are done. Now we've mixed up things a little bit more. On the left side of the scale, not only do we have these identical unknown masses with mass x, these 3 blue things, we also have some of the 1 kilogram masses over here. We actually have 2 of them. So now we're going to try to figure out what x is. But before we even do that, what I want you to think about is a mathematical equation that can represent what is going on right here, that equates what we have on the left hand here to what we have on the right side of the scale right over there. And I'll give you a few seconds to think about it. So let's think about what we have on the left side here. We have 3 masses with mass x. So you can say that we have 3x over here. We have 3 x's. And then we have 2 masses of 1 kilogram. So in total we have 2 kilograms. So plus 2. So one way to think about it, the total mass on the left-hand side is 3x plus 2. 3 masses with mass x plus 2 kilograms. That's what we have on the left-hand side. Now let's think about what we have on the right-hand side. We just have to count these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 blocks each have a mass of 1 kilogram, so the total mass right over here is going to be 14 kilograms. So we get, and we see that the scale is balanced. It's not tilting down or upwards. So the scale is balanced. So this mass, this total mass right over here, must be equal to this total mass. The scale is balanced. So we can write an equal sign. We can do that in that white color, that brown. We can do it in that white color. Now, what I want you to think about, and you can think about it either through the symbols or think about it through the scale, is how would you go about, let's think about a few things. How would you first go about at least getting rid of these little 1 kilogram blocks over here? And I'll give you a second to think about that.
Subtract 2 to both sides.
Well, the simplest thing is, you could take these 1 kilogram blocks off of the left-hand side. But remember, if you just took these 1 kilogram blocks off the left-hand side, and it was balanced before, now the left-hand side will be lighter and it'll move up. But we want to keep it balanced so that we can keep saying equal, that this mass is equal to that mass. So if we're going to remove 2 blocks from the left-hand side, we need to remove 2 blocks from the right-hand side. So we can remove 2 there, and then we can remove 2 right over there. And mathematically, what we're essentially doing is we're subtracting 2 kilograms from each side. So we're subtracting 2 from this side. So on the left-hand side, we now have 3x plus 2 minus 2. We're just left with 3x. We're just left with 3x. And on the right-hand side, we had 14, and we took away 2. Let me write this. We took away 2, so we're going to be left with 12. We're going to be left with 12 blocks. And you see that there. The ones that I haven't crossed out, there's 12 left, and here you only have 3 of those x blocks. And since we removed the exact same amount from both sides, our scale is still balanced. And our equation, 3x, is now equal to 12. And now this turns into a problem very similar to what we saw in the last video. So I will ask you, what can we do to isolate 1x, to only have 1x on the scale while keeping the scale, or 1x on the left-hand side of the scale, while keeping the scale balanced?
Divide both sides by 3.
So the easiest way to think about it is, if I want 1x on this left-hand side, that's 1/3 of the total x's here. So what if I were to essentially multiply the left-hand side by 1/3? But if I want to keep the scale balanced, I have to multiply the right-hand side by 1/3. And so if we can do that mathematically, so right over here, I can multiply the left-hand side by 1/3. But if I want to keep my scale balanced, I also have to keep the right-hand side. I have to multiply the right-hand side by 1/3. And multiplying it physically, that literally means just keeping 1/3 of what we had here originally. So we would get rid of 2 of these. And if we want to keep 1/3 of what we had here originally, there are 12 blocks left over after removing those first 2. So 1/3 of 12, we're only going to keep 4 of these little 1 kilogram boxes left. So let me remove all but 4. So we're going to move those and remove those. I have left 1, 2, 3, 4 here. And so what you're left with, the only thing you have left is this x. This x, I'll shade it in to show this is the one that we actually have left. And then we have these boxes. We have these 1 kilogram boxes. And you see it mathematically right over here, 1/3 times 3x. Or you could have said 3x divided by 3. Either way, that gives us, you could say that these 3's cancel out. That'll give you just an x. And then on the right-hand side, 12 times 1/3, which is the same thing as 12 divided by 3, is equal to 4. And since we did the same thing to both sides, the scale is still balanced. And so you see that the mass of this thing must be the same thing as the mass of these 4 leftover blocks. X must be equal to 4 kilograms.
Let's try some slightly more complicated equations. Let's say we have 3 times x plus 5 plus 5. I want to make sure I get all the colors nice. Plus 5 is equal to 17. Is equal to 17. So what's different about this than what we saw in the last video is all of a sudden now we have this plus 5. If it was just 3x is equal to 17, you could divide both sides by 3 and you would get your answer. But now this 5 seems to mess things up a little bit. Now before we even solve it, let's think about what it's saying. Let's solve it kind of in a tangible way, and then we'll solve it using operations that hopefully will make sense after that. So 3 times x literally means, so let me write it over here. So we have 3 times x. So you literally have an x plus an x plus an x. That right there is a 3x. And then that's plus 5. And I'm actually going to write it out as 5 objects. So plus 1, 2, 3, 4, 5. This right here is 3x plus 5 is equal to 17. Is equal to 17. So write the equal sign. Is equal to 17. Now let me draw 17 objects here. Oh my God. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, these two things are equal. So anything you do to this side, you'd have to do to that side. If we were to get rid of one object here, you'd want to get rid of one object there in order for the equality to still be true. Now, what can we do to both sides of this equation so we can get it in the form that we're used to, where we only have a 3x on the left-hand side, where we don't have this 5? Well, ideally, we would just get rid of these 5 objects here. You would literally get rid of these 5 objects. 1, 2, 3, 4, 5. But like I said, if the original thing was equal to the original thing on the right, if we get rid of 5 objects from the left-hand side, we have to get rid of 5 objects from the right-hand side. So we have to do it here too. 1, 2, 3, 4, 5. Now, what is a symbolic way of representing taking away 5 things? Well, you're subtracting 5 from both sides of this equation. So that's what we're doing here when we took away 5 from the left and from the right. So we're subtracting 5 from the left. That's what we did here. And we're also subtracting 5 from the right. Do that right over there. Now, what does the left-hand side of the equation now become? The left-hand side, you have 5 minus 5. These cancel out. You're just left with the 3x. You are just left with, it's a different shade of green. You are just left with the 3x. The 5 and the negative 5 canceled out. And you see that here. When you got rid of these 5 objects, we were just left with the 3x's. This right here is the 3x. And the whole reason why we subtracted 5 is because we wanted this 5 to go away. Now what does the right-hand side of the equation look like? So it's 3x is going to be, let me write the equality sign right under it, is equal to, well, you can either just do it mathematically, say, okay, 17 minus 5, 17 minus 5 is 12, or you could just count over here. I had 17 things, I took away 5, I have 12 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. That's what subtraction is. It's just taking away 5 things. So now we have it in a pretty straightforward form. 3x is equal to 12. All we have to do is divide both sides of this equation by 3. So we have, so we're just left with an x on the left-hand side. So we divide by, let me pick a nicer color than that. Let me do this pink color. So you divide the left-hand side by 3, the right-hand side by 3. And remember what that's equivalent to. The left-hand side, none of this stuff exists anymore, so we should ignore it. None of this stuff exists anymore. In fact, let me clear it out just so that we don't even have to look at it. We subtracted it, so let me clear it. Let me clear it over here. Let me clear it over here. And so now we are dividing both sides by 3. Divide the left-hand side by 3. It's 1, 2, 3. So 3 groups, each of them have an x in it. If you divide this right-hand side by 3, let's see, you have 1, 2, and 3. So it's 3 groups of 4. So when you do it mathematically here, the 3's cancel out. 3 times something divided by 3 is just a something. So you're left with x is equal to, and then 12 divided by 3 is 4. X, 3's cancel out. 3 times something divided by 3 is just a something. So you're left with x is equal to, and then 12 divided by 3 is 4. 12 divided by 3 is 4. You get x is equal to 4. And you get that exact same thing over here. When you divided 3x into groups of 3, each of the groups had an x in it. And when you divided 12 into groups of 3, each of the groups have a 4 in it. So x must be equal to 4. X is equal to 4. Let's do another one. And this time I won't draw it all out like this, but hopefully you'll see that the same type of processes are involved. Let's say I have, let me scroll down a little bit. Let's say I have 7x, so 7x, 7x. I'll do a slightly more complicated one this time. 7x minus 2 is equal to, let's say, I'll make the numbers not work out nice and clean, is equal to negative 10. Now this all of a sudden becomes a lot more, you have a negative sign, we have a negative over here, but we're going to do the exact same thing. The first thing we want to do if we want to get the left-hand side simplified to just 7x is we want to get rid of this negative 2. And what can we add or subtract to both sides of the equation to get rid of this negative 2? Well, if we add 2 to the left-hand side, these two guys will cancel out. But remember, this is equal to that. If we want the equality to still hold, if we add 2 to the left-hand side, we also have to do it to the right-hand side. So what is the new left-hand side going to be equal to? So we have 7x, negative 2 plus 2 is just 0. I could write plus 0. I could just write nothing there, and I'll just write nothing. So we get 7x is equal to, now what's negative 10 plus 2? This is a little review of adding and subtracting negative numbers. Remember, I'll draw the number line here for you. If I draw the number line, so this is 0, this is 1, you can keep going in the positive direction. Negative 10 is out here. Negative 10, negative 9, negative 8, negative 7. There's a bunch of numbers here, dot, dot, dot. I don't have space to draw them all, but we're starting at negative 10. And we're adding 2 to it. So we're moving in the positive direction on the number line. So we're going 1, 2. So it's negative 8. Don't get confused. Don't say, okay, 10 plus 2 is 12, so negative 10 plus 2 is negative 12. No. Negative 10 minus 2 would be negative 12, because you're going more negative. Here, we're having a negative number, but we're going to the right. We're going in the positive direction. So this is negative 8. So we have 7x is equal to negative 8. So now you might be saying, well, how do I do this type of a problem? I have a negative number here. You do it the exact same way. If we want to just have an x on the left-hand side, we have to divide the left-hand side by 7. So that's a 7x divided by 7. Just 7's cancel out, and you're left with x. So let's do that. If you divide by 7, those cancel out. But you can't just do it to the left-hand side. Anything you do to the left, you have to do to the right in order for the equality to still hold true. So let's divide the right by 7 as well. And we are left with just an x. Just an x is equal to negative 8 divided by 7. We could work it out. It would be some type of a decimal if you were to use a calculator. Or you could just leave it in fraction form. Negative 8 divided by 7 is negative 8 sevenths. Negative 8 sevenths, or if you want to write it as a mixed number, x is equal to, 7 goes into 8 one time and has a remainder of 1, so it's negative 1 and 1/7. Either one would be acceptable.
Okay, what do we do next?
We have the equation negative 16 is equal to x over 4 plus 2, and we need to solve for x. So we really just need to isolate the x variable on one side of this equation. And the best way to do that is first to isolate this whole x over 4 term from all of the other terms. So in order to do that, let's get rid of this 2. And the best way to get rid of that 2 is to subtract it. But if we want to subtract it from the right-hand side, we also have to subtract it from the left-hand side, because this is an equation. If this is equal to that, anything we do to that, we also have to do to this. So let's subtract 2 from both sides. So you subtract 2 from the right, subtract 2 from the left, and we get, on the left-hand side, negative 16 minus 2 is negative 18. And then that is equal to x over 4, and then we have positive 2 minus 2, which is just going to be 0. So we don't even have to write that. I could write just a plus 0, but I think that's a little unnecessary. And so we have negative 18 is equal to x over 4. And the whole goal here is to isolate the x, to solve for the x. And the best way we can do that, if we have x over 4 here, if we multiply that by 4, we're just going to have an x. So we can multiply that by 4. But once again, this is an equation. Anything you do to the right-hand side, you have to do to the left-hand side, and vice versa. So if we multiply the right-hand side by 4, we also have to multiply the left-hand side by 4. So we get 4 times negative 18 is equal to x over 4 times 4. The x over 4 times 4, that cancels out. You divide something by 4 and multiply by 4. You're just going to be left with nx. And on the other side, 4 times negative 18, let's see, that's 40. Well, let's just write it out. So 18 times 4, if we were to multiply 18 times 4, 4 times 8 is 32. 4 times 1 is 4, plus 1 is 72. But this is negative 18 times 4, so it's negative 72. So x is equal to negative 72. And if we want to check it, we can just substitute it back into that original equation. So let's do that. Let's substitute this into the original equation. So the original equation was negative 16 is equal to, instead of writing x, I'm going to write negative 72. Is equal to negative 72 over 4 plus 2. Let's see if this is actually true. So this right-hand side simplifies to negative 72 divided by 4. We already know that that is negative 18. So this is equal to negative 18 plus 2. This is what the equation becomes. And then the right-hand side, negative 18 plus 2, that's negative 16. So it all comes out true. This right-hand side, when x is equal to negative 72, does indeed equal negative 16.
Why? Okay, what are the... tricks... subtract 6 and then multiply by 3. Okay. Better safe than sorry, true. Okay, cool. What is this? 48. Okay, so add 5, we have 48. And 28. Actually 6. Oh my god. 8 times 8 is 64. Okay. So add 1, we get 4. And multiply by 6 to be like 4, right? Okay, cool. What's next? I'm gonna do two-step equations. 7 questions, okay? Let's see, we have 40. So 11 minus 6 is gonna be 30. What's 33? Oh wow, it's gonna be 3, right? Not really. Well, give it negative 3. Just start with then subtract by 11. Oh, it's cool. Okay, solve for P. Wow, what the fuck? Okay, so we can distribute 9p minus this is 36. So add 36, we have 9p equals 18, so we get 2. Okay, whatever, we get 11. 11 over 4, are we satisfied with that? Let's see, I could be wrong. Okay, 4 equals minus oh, no, it's gonna 44. Wow, I almost got debated. We have 2y plus 4 equals 6. 2y plus 2, so 1. Solve for r minus 8 to negative 21 equals r or 9, so 21, 9, 9, 18, negative 1 and 9. Okay, what's this? Solve for w. Okay, so I have negative 4w minus 4 equals negative 24. Add negative 20 equals negative 4w. 4 get 5, bitch. Okay, cool. Minus 5, we get 8. 2, 4. Okay, cool. 6 minutes in already? It's insane, dude. Wow, I'm almost close.
On your math quiz, you earn 5
Oh man, I'm gonna take a break.
points for each.
Alright, I'm back. Recording.
You earn 5 points for each question that you answer correctly. In the table above,
Inequality.
on your math quiz, you earn 5 points for each question that you answer correctly. In the table above, Q represents the number of questions that you answer correctly on your math quiz, and P represents the total number of points that you score on your quiz. The relationship between these two variables can be expressed by the following equation. P is equal to 5Q, where P is the points you get and Q is the number of questions you answered correctly. And you can see that in the table. If Q is 0, if you got no questions right, you get 0 points. If you got no questions right, well, 5 times 0 is going to be 0. If you get 1 question right, well, 1 times 5 is 5. You get 5 points per question. 2 questions right? Well, 2 times 5 is 10. 2 times 5 is 10. 3 times 5 is 15. So this all makes sense. So then they ask us, which of the following statements are true? Check all that apply. So let's think about this. They say the dependent variable is the number of points you score. So when you think about what's happening here, is your number of points you score is being driven by how many questions you get right. It's not like somehow the teacher says you got 15 points and now you have to get exactly 3 questions right. It's the other way around. The number of questions you get right is the independent variable, and that's driving the number of points you score. So the number of points you score is the dependent variable. And typically the convention is to have the dependent variable being equal to some expression involving the independent variable. And you see that right over here. P is dependent on what happens to Q. Depending on the number of questions, you multiply it by 5 and you get P. So the dependent variable is the number of points you score. The dependent variable is the number of questions you answer correctly. No, we've already talked about that. That's the independent variable. The independent variable is the number of points you score. No, that's not right. That's the dependent variable. The independent variable is the number of questions you answer correctly. Well, that's right. That's what's driving the dependent variable. And we can check our answer.
Dependent and independent variables. Graphing.
On your math quiz, you earn 5 points for each question that you answer correctly. In the table below, X represents the number of questions that you answer correctly, and Y represents the total number of points that you score on your quiz. Fair enough? The relationship between these two variables can be expressed by the following equation. Y is equal to 5x. Graph the equation below. So you could look at a couple of your points. You could say, well, look, if I got 0 questions right, I'm going to have 0 points. So you could literally graph that point. If I got 0 questions right, I get 0 points. And then if I get 1 question right, and the table tells us that, or we could logically think about it, every question I get right, I'm going to get 5 more points. So if I get 1 question right, I'm going to get 5 more points. And we saw that in our table as well. We saw that right over here. 1 question, 5 points. We could also have plotted 2 questions, 10 points, any of these. But you only have to do 2 points to define a line. So it looks like we are actually done here.
Wait, what?
1 question right, I'm going to get 5 more points.
Oh, okay.
And we saw that. Let's see, we have this graph over here with t is the independent variable on the horizontal axis, and d is the dependent variable on the vertical axis. And then they have a table here. It looks like this table corresponds to this graph. When t equals 1, d is 40. When t is equal to 2, d is 80. So these points correspond to points on this line. And then they explain to us, you are buying a gym membership. The membership costs $40 per month. In the graph and table above, D is the total number of dollars that you pay for your gym membership, so that's D right over there, and T is the time in months that you keep the membership. Write an equation for the amount of money D that you pay for your gym membership if you keep the membership for T months. And you see that here. If you're 1 month, you pay $40. 2 months, you pay another $40. You pay $80. You see that in the graph right over here. If you have 0 months, you pay nothing. Then 1 month, $40. The next month, another $40, getting you to $80. So if I were to write this as an equation, well, the dependent variable here is the amount that I pay in dollars. So that is going to depend on the time. And how is it going to depend on the time in months? Well, I'm going to pay $40 per month times the number of months. So I can either write it as 40 with a little asterisk sign, which is shift 8, or I could literally, and then I put t there, or I could literally put just a t right over there. And I think that's right, because if my time is 0, according to this table and according to this graph, I pay nothing. If there was some initial membership charge, then maybe we would add that membership charge and you would pay the monthly fee after that. But here, this looks about right, that the dollars paid is equal to 40 times the time in months. The time in months is the independent variable. It drives the dependent variable, the number of dollars you pay.
An independent variable is a variable that represents a quantity that is being manipulated in an experiment. Independent. You're doing chores to earn your allowance for each chore you do earn. What's the independent variable? Oh, wait, what? This is the independent. Oh, what? Independent variable is the amount of chores you do. This is the variable you have control over. Independent. To earn your allowance. That's confusing. The dependent is the amount of money you earn, because the amount of money you earn depends on how many chores you do. Okay, you're buying boxes cookies at a bakery. Each box costs $4. The dependent variable is the variable is the number of boxes of cookies you buy. The dependent variable is the amount of money you spend on the cookies. Wait, what? Holy shit, this is insane. Okay. What is something I have control over? I mean, it looks like 4, but in this example, it's not. The number of chores is the dependent. Oh, okay. This is independent, right? Dependent. Ah, this is insane. I mean, the number of boxes of cookies you buy, that depends on how much money you have, though. Okay. That's so fucking weird. You are walking directly away from your house. You are 5 miles away from your house, and you start walking. Okay. This shit? Oh shit, oh god, it's a distance from your home. Yeah, the soundtrack of my summer. Ready to practice? Okay, 4 questions. Okay. On your math quiz, you earn 5 and first round. In the question below, X represents the number of questions you answer correct on your math quiz. Can be expressed by the following equation. The total number of dependent variable. Oh, okay. Total number of points you score is your independent. No, actually it's a dependent. Independent variable. Let's go. Your grandmother always has a jar of cookies on her counter. One day, while you are visiting, you ate 5 cookies from the jar. In the equation below, C is the number of cookies remaining in the jar, and B is the number of cookies. You have set a goal to drink more water every day. Your bottle holds a half liter of water. In the equation below, B is the number of times you drink all the water in your bottle. B is the number of times you drink all the water in your bottle. Okay. The relation between you're buying a new internet service. The service is $100 per month. Wow, it's expensive. It's expensive, man. In the equation below, D is the total number of dollars you have paid. Okay, the dependent variable is the number of dollars you pay. Time in months is the independent variable. Okay, cool. Tables from equations with two variables. Okay, cool. Complete the table for the given rule. Y equals x minus 4. Okay. Then 4, 8, I guess. Yo, is this correct? I don't know. 10 minus 4, 6. 10 minus 4 minus 4, 6 minus 4, 4. Okay. Um, 18, 5, 2, yes. X is 1. Okay, this would be 2, 18 minus 4 is 14. 60, 56, I guess. Oh my gosh, I could be wrong. Let's see. X minus 4, 2 times 3, 18 minus 4 is 14. 60 minus 4 is 6. Plus 0.6, okay? 3.6, 4.8, and 2.6. What? Plus 0.6. Oh shit. Oh god. Oh my god. Oh my god. Plus a fraction? Are you kidding me? X 3/9 over 3. No, actually it's 10 over 3. 22 over 3. 24 over 3. Wait, what? Oh shit! I got the first one wrong. Oh, wow, still wrong. What? Oh shit, of course. It's 1/3, it's 4/3. God damn, son. God damn. Okay, I deserve that loss. Okay. 0, I guess. Oh. 13 over 4. Over 4 or 3. 2 minus 1/4. Oh my god, what is this? What's 75? Y is 1, so it's going to be 2x. Wow, what is this? 2.5? 2, 4, 5. Gonna be 7. X minus 3. Okay, what's this? 4. 4. And then, god damn it, I made a mistake again. Um, 4x. X is 4, then it's gonna be 12 and 16, please. X plus 3. Okay, 1 plus 3 is 4. 5 plus 3 is 8. 2 plus 3 is 5. Okay. 12 minus 5 is 7. And 30 minus 5 is 25. 10. Okay. Wow, it's multiplied by x. That's insane. Okay, divide by 3, we got 4, 1, and 6. Word problems. Let's go. X and Y were in the following graph. Okay, this one. This. So if your x is 2, then your y is gonna be 3. Now let's do x is 4. Then our y is 9. Two, 4. It's double. Y equals 2x is true. Okay. Or let's do 2, 4. This one seems to it. 4, 8, 6, 12, 5, 10. One more, then we're gonna do the quiz and then the unit test. Your voice is a soundtrack on my. You and your brother are reading the same novel. You want to get ahead of him in the book, so you decide to read 30 minutes longer than your brother reads. Maybe 4 or 5. The most points Sydney has scored in a basketball game is 28. She is trying to tie that record in her current game. Write an equation for the number of points Sydney needs to score to tie her record. R. If she already has P points.
Whoa, this is hard. What is this?
Oh. The number of points need to score to tie her. Okay. She already has P points. Okay. This new chair spirits sick. Forward tilting bitch. Okay. So we have 28, then minus 14. We get 14, so 28 minus 16, so we get 12, I guess. Makes sense. Mr. Ledger buys a box of 24 donuts for a lesson in his math lesson with circumference. Write an equation for a number of donuts y that are left at the end of the day when X donuts are used during the lesson. Okay, the first one is uh 18 donuts, 18, and then 24 minus 18. How much is that? It was 6. Then we have 22 minus 24 with 2 over here, right there. Buddy, right there. Are we correct? 24 minus 18 is 6. Yeah, that is correct. 2, 6, 18. Okay. You and your best friend are both on the swim team. You want to beat your friend at the next swim meet, so you decide to swim. Friend swim. Okay, let's go for the quiz number 7. Complete the table for the given rule. Yeah, 16 divided by 4 is 4. And 4 divided... No. 8 divided by 4 is 2. I mean, can I just multiply this? 4 times 9 is 36. That's correct, right? So 4 times 4 is 16, 4 times 2 is 8, 4 times 9 is 36. So just gonna do an inverse operation. Sean's mom asks how long his homework will take. He tells her dad that he needs to read 25 minutes. Okay, plus 25, 45, 50, 55. Cool. Which rule describes the relationship between x and y coordinates on the following path? Okay. 2, 3, 3, and... Oh no, it's actually this one. 4 minus 1, 6 minus 1, 5, 8 minus 1, 7. You're in an elevator that's already filled with several people. You wonder if your weight will put the elevator over the maximum weight limit. You know your weight is 130 pounds. In the equation below, P is the weight of all people already on the elevator, and T is the total weight after get on. The dependent variable is the total weight, and P is the number of people. Wait, P is the weight of people. Okay, and T is the total weight inside the elevator. Inside the elevator after you get on. Okay. Solve for T. Okay, cool. Let's see. Times 2 is going to be 10, so 4 plus 1, 5 plus 2, 10. Cool, let's go. Oh man, let's go. Unit test. Oh man, it's gonna be crazy. This is gonna be 28 questions. Oh man, this is insane, bro. Ah, so good. So if this is 8 divided by 2, it's gonna be 4. 14 divided by 2 is 7. And then 6 divided by 2 is 3. You're going running. You're going running. For every mile you run, you burn 100 calories. In the question below, M represents the number of miles you run, and C represents the number of calories you burn. Okay. The number of miles you run is independent, and the number of calories you burn is the dependent variable. The temperature on Tuesday was -5 degrees Celsius. is 5 degrees Celsius. Write an inequality that compares to the temperatures. -5 is less than 5. The temperature was higher on Wednesday than on Tuesday. Temperature was higher on Wednesday than on Tuesday. Tuesday was negative. Write an inequality, -5 is less than. Okay, cool. Let's see. The tape diagram represents the equation. Write an equation to represent the image. It's supposed to be like this, right? 2.7 is equals to 1.3 plus double. Solve the equation. Oh wow, this is insane. Okay, cool. Let's do 30 divided by 10. It's gonna be 10. It makes sense. You go multiply this by 5, multiply 5 by 10. If you multiply 2 by 15, you get 30 divided by 3, it's 10. Right expression represents a sound more than a quotient of 72 by 9. Okay, cool. 175. This one is quotient of 70 divided by 9 and added 175 to that. Cool. Makes sense. Write an expression to represent the sum of 10 and the quotient of a number x divided by 6. Choose the inequality that represents the following graph. Okay. So this is x is less than 3. After Luca took his dogs for a walk, he gave them 6 dog treats. When Luca's dad got home from work, he gave the dog more treats. Altogether, that day, Luca's dogs get 10 dog treats. What? Okay. What? Is it supposed to be like this? After Luca took his dogs for a walk, he gave them 6 dog treats. When Luca's dog got home from work, he gave the dog 10 more treats. Altogether, they... Oh my god. How many dog treats did Luca's dad give to the dogs? 4. Let's do this one more time. After Luca took his dogs for a walk, he gave them 6 dog treats. When Luca's dad got home from work, he gave the dogs 3 more treats. Altogether, the Luca's dogs got 10. Let's see. Okay, this is not 7h. This is 7 plus 13. Is that correct? Yeah. What happens to the value of expression q as q decreases? Oh wow, cool. Let's see if it decreases as well. I mean, if you have 20 divided by 20, let's do 100 divided by 20, it's going to be 5. If you divide 80, it's going to be 4. 520 is going to be Okay. Let's go. Please. Although you love to watch 20 TV, have made a goal to spend more time outdoors. You decided you will spend 2 times as many hours outdoors as when watching TV. An equation for the number of hours you'll spend outdoors. Last week you watched 4 hours of TV. Okay, let's do TV hours 4 and then twice that's gonna be 8. This week you watched 8 hours of TV. This was 16. Okay, 4, 8, 8 hours, 16. Onward. Gina wants to go to the water park with her friends. You have a total of $double to buy tickets. To buy 5 tickets. Each dollar costs 15. Okay, your total cost is gonna be 5 times 15. Let's see this again. You know, to go to the water park with your friends. They have a total of $double to buy 5 tickets. Each ticket costs $15. 60 is the total number of dollars to. Oh my god, I could be wrong. What's this? 5 is the number of tickets. 15 times the number of. No, that doesn't make sense. It should be B. Carter tried to evaluate the expression. We should start the first mistake. Okay, cool. Let's see. Okay, 24 divided by 8, but 4 times 8 minus 5 is 3. Wow, we didn't make a mistake. Carl is pretty good. Let's see. It's gonna be 8. 4 times is 8. It's gonna be 3. 24 divided by 3 is 8. Alright. 24. 16. 16 plus 8. Yeah, it makes sense. You did not make a mistake. So equation where z equals 5 is a solution. Okay. 5 plus 3 is 8. 5 minus 1 is 4. 40 divided by 5, no? Okay, this one's 21 is 60. Okay, that makes sense. Graph. X is greater than or equal to 0. Okay, this is pretty good. Solve for h. Negative 3. Okay, so we need to make this times 4. So we have 36. No, not really. Minus 1. It's gonna be negative 12. So negative 12 divided by 6. Let's just do this on that. Negative 12 divided by 6 is equals to negative 2 minus 1 is negative 3. Hannah's school also had a book donation. There are 150 students at her school, and they donated a total of B books. Hannah donated 3 times as many as the average number of books each student donated. How many books did Hannah donate? Write your answer as an expression. Wait, what? Write your answer as an expression. Okay. She donated 150 students divided by B times 3. Okay, second. Hannah's school hosted a book donation. There are 150 students at her school. Oh god. This is, and they donated a total of B books. Okay, so get the number of average of, so 150. We divide the number of books, so if the total number of books was 600, then each student would give 4 books, but times 2 of that would be the average number of books each student donated. Okay, this makes sense. Cool. Kellen neighbor went out of town for 9 days. The table shows the work she did for her neighbors and how much they paid her for each task. What? Went out. Oh, okay. Dog walking. Oh, it's 7 plus 2 plus 3 times 9. 7 plus 2 plus 3 times 9? Nope. Okay, cool. Oh, wow. 1, 2, 3, 4, 5, 6, 7 times 7 is 49. That's the only thing. Factor of 49 is only 7 and 7. And 1 of 149, of course. Which graph represents... So 1 would be... 2 would be 1. So it is 5. No. X, y would be half of x. Let's see. Okay. 5, half of that is 2.5. Oh, there we go. 4, half of that 2, 6 half of that 3, 8x half of that is 4. One answer? Okay. Compared, oh wow, it's pretty easy. Cool. Let's do this one. It's greater than 35. It's not negative or anything. Not the best order. Okay. This one's an equation. This one's equality and an expression. The expression 1.08s plus 1.02b predicts the end of year value of a financial portfolio, where S is the value of stocks and B is the value of bonds in the portfolio at the beginning of the year. What is the predicted end of year value? With 200 stocks and 100 in bonds. Okay, let's see. Let's multiply 1.08 times 200. This is do I really need to do this? Oh my gosh. Okay. Let's do first. If we just multiply this by 2, then you get 2.16. But since this is by hundreds, you get 216. Oh, that's not enough. Just 216. The first part plus 100. So we have 102. It's gonna be 318. Let's do the traditional way. 1.08 times 200. 0, 0, 0, 0, 0, 0, 0, 0, 0. We have 2 times that thing. It's gonna be 16. 2 and 2, and then we get 116. That's correct. Okay, that's correct. Which also makes sense. All I have to do is add 106, 216 plus 102, 81318. Oh shit, I have a calculator. Oh, calculator, bitch. A calculator, bitch. I don't need a calculator, I'm correct. Okay, let's do this anyway. Let's see, 108 times 200 plus 1.02 times 100. Yo, what? One times 200 plus 2 times 102 times 100. The fuck, it doesn't even fit. 0.8 times 200. Where m is 21 minus 1 minus 1/2 12. Okay, it's gonna be 6, this one. Minus 1, it's gonna be minus 7. 1/2 21. And 10 minus 7 is just a good 5, I guess. Let's do this again. Oh, this is 1/3. Oh my god. 1/3. So we have 7. Let's do 21 divided by 3 is 7. Minus 1, that's 6. Minus half of 12. Oh, 0. I got 0. Cool. One more time. Half. 3 is 7 minus 1 is 6 minus the half of 12 is 0. Okay. Mariana wears her winter coat when the temperature is colder than -4 degrees Celsius. Write an inequality that's only true only for temperatures at which Mariana wears her winter coat. It's less than or equal. Not really. It's colder than -4, so it's less than -4. Let's see. Mariana wears a winter coat when the temperature is colder than -4. Oh, so lower than -4 would be colder, right? Okay. So I think this is true only for temperatures T at which Mariana wears her winter coat. Write an equation to represent the following statement. 24 is 4 times as great as K. Wait, what? 24 is 4 times or 4K. Six. Is this correct? Okay. Let's see. 24 is 4 times great. 4 times as great as K. So 24 is 4 times as great as 6. Makes sense? That makes sense. 24 is oh wow, cool, this one's pretty easy. So if this was just 8 minus 5, then you get 3. So if this is 8.4, we'll have 8.4. Oh! I have no faith in myself? What the fuck? It's just really paranoying the unit test because there's a lot of questions and you can't afford to make one mistake. Okay, cool. That's it for now. So we mastered this section: equations, expression, and inequalities. Okay, 100% mastered. That's cool. How much are we in our pre-algebra now? 93%. Wow, it's pretty insane. Okay, last thing is this: exponent, radicals, and scientific notation. Okay. Let's see. Let's your notifications. Nice listener. Nice stuff. Okay. Got 2. Wow. 2? You're right. 26% in the world of math. And for that one, that's the thing. So current progress. Okay. This is part 21. And it's been spread for like many days. I mean, I skipped some days. Just gonna put it in one video. Part 21. Cool, bye, thanks.